Good morning to all. In the last lecture, seen that theorem statement of the theorem. Okay, which one? If f of x belongs to capital F of x, it's irreducible. Then we have to prove that if the characteristic of f is zero, then f of x has a no multiple root. And if f of x has a characteristic p which is not equal to zero, then f of x has a multiple root only if it is in the form of f of x is equal to g of x raised to p for some g of x belongs to capital F of x. Okay. And last theorem, we see that what is the condition for the multiple root? The polynomial f of x belongs to capital F of x has a multiple root if and only if f of x and f dash of x have a non-trivial common factor. Okay. So before going to this theorem, we see in one step number one result. Which theorem? Which result? If f of x and g of x. Look at here. If f of x and g of x belongs to capital F of x, have a non-trivial common factor in k of x, where k is the sub-extension of f, then they must have a non-trivial common factor in f of x. Okay, look at here. If f of x and g of x, these are the two polynomials. Okay, which has a non-trivial common factor in k of x. Okay, larger field. Then it must have the non-trivial common factor in f of x also. म्हणजे त्याचा सबफिल्ड वरती काय असायला पाहिजे नॉन ट्रिवियल कॉमन फॅक्टर एक्झिस्ट असायला हवा ओके ना look at the proof of this theorem. What is f of x given here? F of x is an irreducible element. Okay, proof. Part 1. What is the part 1? Wait a minute. Part 1 is let this is the f of x belongs to capital F of x be irreducible. Okay, what is the meaning of irreducible? We cannot write in the form of product of two polynomials belongs to this f of x. Okay, such that the degree of that two polynomial is less than f of x. Okay, so here let f of x belongs to capital F of x be irreducible and the characteristic of the field f. Okay, characteristic of f is 0. That's the what is the meaning of this sentence? The field must be infinite. If here the given is characteristic of f is 0, then it implies that field must be an infinite field. Okay, and सांगायचा अर्थ काय ह्यांचा characteristic of f is equal to 0 means that field is infinite. Okay, so here the rate of f of x is irreducible and the characteristic of f is 0. We have to prove that f of x has no multiple root. Okay, we have to prove that f of x has no multiple root. Look at this. Characteristic of f is 0, then f of x has no multiple root. Okay, suppose contradiction statement. F of x has a multiple root. F of x has a multiple root. Okay, by previous theorem. Okay, by above theorem. What we have? F of x and f dash of x, that is the derivative of x, have a non-trivial common factor in f of x. Is it correct?
Yes, sir.
Okay, f of x and f dash of x has a non-trivial common factor in f of x by previous theorem. if the f of x has a multiple root. Okay. Now, since f of x हा एफ ऑफ एक्सला आणि एफ डॅश ऑफ एक्सला काय म्हणतोय का नॉन ट्रिवियल कॉमन फॅक्टर म्हणजे असा ह्या एफ ऑफ एक्सचा एक फॅक्टर एक्झिस्ट होतोय that factor must be divides this f of x. Okay, but what is given to us since f of x is irreducible, so reduces होत नाही. Okay, irreducible. Therefore, it's only non-trivial common factor is itself f of x. Is it correct?
Yes, sir.
Okay, now f of x is irreducible असेल, so we cannot write in the form of product of two polynomials such that the degree of that two polynomial is less than f of x. Okay, since f of x is irreducible, therefore its only non-trivial common factor itself, that is f of x divides f of x. Okay, so this implies f of x. इथे काय म्हणते f of x and f dash of x have a non-trivial common factor in f of x. That means this f of x is factor of f dash of x. Okay, since the degree of f dash of x is less than f of x, therefore f of x ह्याच्यामधनं काय लिहिता येईल आपल्याला since here look at it f of x is the factor of f dash of x. That means f of x here what divides f dash of x, but degree of f dash of x is what less than degree of f of x. So this implies by the previous theorem f dash of x must be zero polynomial. Okay, हा तुमचा काय असायला हवा f dash of x zero polynomial, because here the f of x divide f dash of x, but f dash of x, the degree of f dash of x is less than degree of f of x. So we must have this f dash of x is equal to 0. Okay, and here we have characteristic of the field f is what 0, and the flash of x is what 0. Okay, by the previous theorem, this implies f of x is which polynomial?
Constant.
Constant polynomial. Okay, if the characteristic of p is characteristic of f is p, then f of x is in the form of x raised to p. Okay, g of x raised to p. But here characteristic of f is what 0, and also f dash of x is 0. Hence it implies f of x is a constant polynomial, which is contradiction. Which is contradiction. Why? Since we have f of x is irreducible. Okay. Hence, our assumption is wrong. What is our assumption? Suppose f of x has a multiple root is wrong. So what we get? F of x has no multiple root. Okay, which is contradiction since f of x is a irreducible. Hence, our assumption is wrong. Assumption is wrong. That is, f of x have a hmm, multiple root. Multiple root is 1. This implies f of x has a no multiple roots. Any doubt?
No, sir.
Okay. Now, in the part second, if the characteristic of f is p, which is not equal to 0, okay, then f of x has a multiple root only if it is in the form of g of x raised to p. Okay, that f of x is the polynomial in the form of x raised to p. Part 2. Same group as let f of x belongs to capital F of x be irreducible polynomial. Okay, and what is given to us? Characteristic of f is p. Okay, characteristic of f is equal to p, which is not equal to 0. Okay, suppose again assume the contradiction step. F of x has a multiple root by previous theorem again by previous theorem. And what we get is f of x and f dash of x have a non-trivial common factor. Non-trivial common factor. Okay, in capital F of x. Since it is given to us, this f of x is what? Irreducible. Same proof I work. Irreducible in this f of x. Okay, then the polynomial f of x. Therefore, its only non-trivial factor in f of x is what? Factor in
F of x.
capital F of x is itself f of x. Okay, that is itself. Okay, so this implies f of x is a factor of f dash of x. Okay, so this implies f of x divides f dash of x, but degree of f dash of x is less than degree of f of x. Okay, so this implies f dash of x must be 0 polynomial. Okay, now f dash of x is equal to 0 and characteristic of the field f is equal to p, which is not equal to 0. Hence, by previous theorem, look at it. Which one? Which theorem? Okay, by the previous theorem, if f dash of x is equal to 0 and characteristic of f is equal to what? P. Hence, by the previous theorem. Okay,
F of x equal to g of x raised to p.
f of x is equal to g of x raised to p. Okay, आहे बघा 2 दिवसाआधी घेतलेला आहे. Okay, so this implies by the previous theorem, this implies f of x is a polynomial x raised to p. That implies f of x is equal to g of x raised to p for some g of x belongs to capital F of x. Okay, hence the any doubt?
No, sir.
Okay, what we have to do here? Hmm. If f of x belongs to capital F of x with the irreducible, then the characteristic of f is equal to 0, then f of x has no multiple. And if f of x hmm, has a multiple root and the characteristic of f is p, then it implies f of x is in the form of x raised to p. Okay, that is f of x is equal to g of x raised to p for some g of x belongs to capital F of x. Okay, any doubt in this theorem?
No, sir.
Okay, so we will move towards the next theorem. Next, if capital F is a field, capital F is a field of characteristic, characteristic p is not equal to 0. जेव्हा characteristic of sorry characteristic of F characteristic okay, characteristic
Sir, your voice is too low, sir.
okay good. If F is a field of characteristic P which is not equal to 0, okay, then the polynomial then the polynomial x raised to p raised to n, okay, x raised to p raised to n, this is minus x, okay, this is the polynomial, belongs to capital F of x for n greater than 1 has distinct roots. Distinct roots. What is the meaning of distinct root? This polynomial has no multiple roots. Okay, if f is the field of characteristic p is not equal to 0, then the polynomial x raised to p raised to n minus x, okay, for n greater than 1. Okay, this polynomial has a distinct root. Look at that. What is given to us? Let f of x is equal to x raised to p raised to n minus x for n greater than 1. Okay, this implies f dash of x. What is f dash of x? P raised to n into x raised to p raised to n minus 1, and derivative of x is what? Minus 1. Okay, now p belongs to capital F. Okay, here this p belongs to what? Capital F. We mean that we mean p is equal to, we can write p is equal to 1 plus 1 plus 1 plus up to how many times? P times. Okay, any doubt up to here?
No, sir.
Okay, since f is the characteristic of p and we have 1 plus 1 plus 1 up to p times, then what is the value of this one? P is equal to 0. Okay, since since f is of characteristic p, okay, we have times is equal to 0. Okay, which is equal to what? P, na? Hence, hence, P raised to n is equal to what? 0.
0.
This implies f dash of x is equal to minus 1. Okay. This time is 0 and 0 into something is 0. So f dash of x is equal to minus 1. This implies f of x and f dash of x, okay, have no non-trivial common factor. Common factor. Okay. Hence, by previous theorem, okay, by previous theorem, we must have f of x has no
Multiple
multiple
root.
roots. Okay, that is f of x has distinct roots. Okay, any doubt in this theorem?
No, sir.
एक प्रश्न पडला असा असायला कळायला व्हॉट हॅपन्स इफ n इज n हा ग्रेटर दॅनच वन का असायला हवा त्याचा आन्सर मीही ट्राय करतोय शोधायचं तुम्ही ट्राय करा बघ मला याचं
सर
उलगडा
तुमचा आवाज परत हळू यायला खूप.
ओके ओके ठीक आहे व्हॉट हॅपन्स इफ n इज इक्वल टू 1 फाइंड आउट ओके why here n is greater than 1 ओके आपण या थेरम मध्ये कुठेच n इज ग्रेटर दॅन 1 हा यूज केलेला नाही ओके सो फाइंड आउट why n is why not n is equal to 1 okay so this is the homework for you okay now the next theorem okay any doubt in this theorem
No, sir.
okay the next theorem next one is the next theorem okay थोड़ा मोठा आहे theorem त्यामुळे नीट लक्ष द्या ओके इझी आहे पण थोडा किचकट आणि मोठा आहे 3 ते 4 पानाचा theorem आहे हा आज अर्धाच होईल याचा ओके what is theorem says if capital F is capital F is of characteristic 0 okay and if A and B are the two elements are algebraic over the field F okay this capital F then prove that there exist there exist there exists an element C okay belongs to f of AB okay that is the finite extension of f there exists an element C belongs to capital F of AB such that f of AB is equal to f of C. This means capital. What is the meaning of this sentence? If f is of characteristic 0, that means f is the infinite field. Okay, and A and B are the two elements which are algebraic over the field F. Then we have to prove that there exists an element C belongs to this field. Okay, that is the extension of F. such that f of AB is equal to f of C. Okay, or statement for this theorem. If f is of characteristic 0, f is of characteristic 0, and if A and B are algebraic, these are the two elements algebraic over the field capital F, then this f of AB is a simple extension of hmm, simple extension of f. Okay. Hmm. The meaning of this statement is if f is of characteristic 0 and if A and B are the two elements of algebraic over the field f, then f of AB is a simple extension of f. ओके हा इथे सी जॉईन करतोय आपण ऍडजॉईंट करतोय कोणाला एफ ला म्हणजेच हा एफ ऑफ एबी काय सिंपल एक्सटेंशन ऑफ एफ ओके एनी डाउट्स
No, sir.
ओके okay look at the proof f is a field write down all the given things f is a field of characteristic 0 field of characteristic 0 okay and the small a and b small ab are algebra okay algebraic over the field f okay this implies suppose this f of x and g of x be the irreducible polynomial over f capital F satisfied by a and b satisfied by small a and small b respectively okay here f of a is equal to 0 and g of b is equal to what 0 okay and these are the irreducible polynomial that is minimal polynomial for a and b okay which is satisfied by a and b now let the degree of f of x the degree of f of x is equal to m and the degree of g of x is equal to n okay suppose E is an extension of f an extension of capital F okay suppose this one is f as तुमचा E okay E is an extension of the field F in which both f of x and g of x and g of x splits completely splits completely okay that means this E is this fitting field of what f of x and g of x the m roots of f of x and n roots of g of x are in the extension E of the field f. ओके ह्याचे सगळे रूट्स कशामध्ये असतील या फील्डमध्ये असतील ई मध्ये ओके स्प्लिट करतो म्हणजे काय ठरतो तो स्प्लिटिंग फील्ड आहे याचा ओके Suppose E is an extension of F in which both f of x and g of x splits completely. Now, f of x is irreducible. F of x is irreducible and characteristic of f is equal to what? 0. Okay, what is the meaning of this sentence? This implies by previous theorem f of x has
No multiple roots.
no multiple root. Okay, that is all the roots of f of x are distinct. Okay, काय प्रूव्ह करायचं हे नीट लक्षात ठेवा तर तेच समजा f of ab is the a simple extension of f, that is if a and b are the two algebraic elements, then f of ab is equal to c, where c belongs to f of ab. Example is next. Q is the field with characteristic 0, q root 2 root 3, which is equal to 2q root 2 plus root 3. आता कळते there exists an element. This element belongs to this one is q. This one extension of q is r. Okay. Hmm? Or इथे काय येणार q of root 2 plus and root 3. हा याचा extension आहे q चा. Q of root 2 root 3. This is the extension of q. So there exists an element belongs to this field. That which element? Root 2 plus root 3 belongs to this field, such that this both are equal. Okay, कळलं आता?
Yes, sir.
शिकलेलंच आहोत आपण, फक्त ते थेरम स्टेटमेंटच्या रूपात इन जनरलाइज केल्यामुळे आपल्याला अवघड वाटत असेल. Okay, now here the f of x has no multiple. It means all the roots of f of x are distinct. Similarly, all the roots of g of x are also distinct. Okay, g of x splits completely. Here g of x is irreducible. Characteristic of f is 0. That means g of x has no multiple root. Similarly, all the roots of g of x are distinct. Okay, any doubt up to here?
No, sir.
Okay, now look at here. Let what is the degree of f of x? A1, A2 up to Am are the distinct, okay, distinct roots of f of x. And b1, b2 up to so on b
N.
n be the distinct roots, distinct roots of g of x. Okay, now let us put इथून नीट लक्ष द्या, इथून थोडं किचकट पाठ थोडं. Let us put for our sake of convenience a1 is equal to a. Okay, for our simplicity a1 is equal to a and b1 is equal to b. Okay, now look at here. If बीजेस म्हणजे काय b1 b2 up to so on bn. If j is not equal to 1, Okay, why? Because all these are distinct roots. Okay, b1 b2, b1 हा b2 ला इक्वल नहीं है, b1 हा b3 ला पण इक्वल नहीं है. Okay, so here for j is not equal to 1, bj not equal to b1, which is equal to b. Okay, any doubt up to here?
No, sir.
So therefore, in E, capital E, okay, we have AI plus lambda bj is equal to A plus lambda b. For I running from 1 to up to so on m, and j running from 2, 3 up to so on. Yeah, need to actually take that. Okay. Now, yeah, so there is a explanation for answering. So this implies what is lambda? Lambda is equal to ai minus a, okay, upon b minus bj. Look at it. In E, we have ai plus lambda bj, which is equal to what is a? A1. A1 plus lambda b1. Okay, look at here. That's the reason they take us write down the bracket. Look at it. AI plus lambda bj is equal to a plus lambda b for I running from 1 to up to so on n, and j running from 2, 3 up to so on n. We know that a1 is equal to a and b1 is equal to b. Okay, that is ai plus lambda bj is equal to what? A plus lambda b for I is equal to 1 and j is equal to 1. Is it correct? We assume that a1 is equal to a and b1 is equal to b. So a1 plus lambda b1, which is equal to a plus lambda b. Okay. Any doubt in this statement? पूर्ण ऐकामध्ये कळलं. But when we write this equation, which one? ai plus lambda bj is equal to a plus lambda b. Okay, but when we write this equation, it means that we are expecting any value of lambda. Okay, that is for any value of lambda, this equation will be true. There's ai plus lambda j is equal to for I, look at it, even for I is equal to 1 and j is equal to 1, what we get? This is a1 plus lambda b1, which is equal to a plus lambda b. Okay, now look at here. Equation किती देते? एकच equation. Okay, variables 2. Then how many solution for lambda? Okay, for any value of lambda, this equation true. For this value of lambda, this equation is true. Okay, but when we consider the equation 1, what is the equation 1? this one. Wait a minute. तो पुढे आहे question. whatever. थोडं घोळ होते पण नीट लक्ष द्या. समजतंय का इथपर्यंत? हा पाठ समजलाय का तू सांगा मला. हॅलो, आवाज ऐकू येतोय का माझा?
Yes, sir.
जर नसेल तर नाही म्हणून सांगा. ओके, पहा. Look at it. Let us put a1 is equal to a, b1 is equal to b. If j is not equal to 1, what happen? bj is not equal to b1, which is not equal to b. हा यातला bj या b ला इक्वल होणारच नाही. का होणार नाही? कारण की all the roots of g of x are what? Distinct. Okay. So now assume in E we have ai plus lambda bj. What we get? This is equal to a plus lambda b. This implies lambda is equal to ai minus a and b minus bj. Okay. For I running from what? 1, 2, 3 up to so on m, and j running from 2, 3, 4 up to n. What happens if j is equal to 1? J is equal to 1 झाला की इथं हा b1 येईल. b1 is equal to what? b. So b minus b काय होईल हा? 0 होईल. Okay. That's why we have not taken j is equal to 1 here. Okay. Now look at here. ai plus lambda bj is equal to what we get? A plus lambda b. For I running from 1 to m, j running from 2 to m. Now we know that a1 is equal to a and b1 is equal to b. Okay, that is this equation for I is equal to 1 and j is equal to 1, what we get? A plus lambda b. Okay, जेव्हा आपण I is equal to 1 ला आणि j is equal to 1 ला लिहितो, but when we write this equation, it means we are expecting any value of lambda. Okay, कोणत्याही लॅम्बडा साठी हे इक्वेशन कसं असेल? ट्रू असेल. For I is equal to 1 and j is equal to 1. Okay, but when we write, look at it. That is for any value of lambda, this equation will be true. But when consider equation 1, it is true only okay. जेव्हा जेव्हा मी हा I is equal to 1 and j is equal to what? For I is equal to 1 to m and j is equal to 2 to m. So, but when we consider the equation 1, it is true only for the particular value of lambda. What is equation 1? This one. This equation. Has equation 1. Okay. Okay. Any doubt? जर नाही समजला तर पुन्हा व्हिडिओ पहा, पुन्हा एकदा वाचा व्यवस्थित. ओके. रिप्लाय द्या काहीतरी, हो किंवा नाही.
Yes, sir.
ओके, नसेल तर पुन्हा सांगतो. पहा, लॅम्बडा इज इक्वल टू ai मायनस ए अँड अपॉन बी मायनस बी जे. जे 1 पासून काय घेतला मी? If we put j is equal to 1, this bj is equal to b1. But b1 is equal to b, so b minus b is 0. So lambda here, we cannot define lambda. Okay. So for I running from 1 to m and j running from 2 to n, we get a particular lambda. Okay. But whenever we put I is equal to 1, j is equal to 1. Okay. So for any value of lambda, this equation will be true. Okay, which one? This one. Okay, just okay. वाचा पुन्हा जर नाही समजलं पुन्हा वाचा. Okay, look at it. If a1 is equal to a and b1 is equal to b, that is ai plus lambda bj is equal to a1 plus lambda b1, which is equal to a plus lambda b, for I is equal to 1 and j is equal to 1. But when we write this equation, it means that we are expecting any value of lambda. Okay, that is for any value of lambda, this equation will be true. But when we consider when I running from 1 to n, j running from 2 to n, we get the particular lambda. Okay, सुरुवातीला असल्यामुळे थोडा समजायला अवघडही जाईल. Okay, so this is the bracket. So what we get here, lambda is equal to ai minus a divided by b minus bj. So here lambda is equal to ai minus a divided by b minus bj, which is a unique element in capital E. Okay, that extension field F of extension field F, that is E. Thus, for each pair of I and J, look at it, for each pair of I and J, provided J is not equal to 1. Okay, the equation ai plus lambda bj, which is equal to a plus lambda b, has only one solution. In any doubt? Thus, for each pair of I and J, provided J is not equal to 1, that is I running from 1 to m and J running from 2 to n, we get only one lambda for each pair. Okay. Okay. So
Yes,
has
sir.
only one solution in E by putting I is equal to 1, 2 up to so on m, and J is equal to 2, 3 up to n. Okay. By putting I is equal to 1 to n and J is equal to 2 to n, the equation ai plus lambda bj is equal to what we get, a plus lambda b, can take only finite number of forms. Okay, if we run this I and j, we get finite number of the forms of lambda. Okay, what is lambda? This one, ai minus a and b minus bj. Okay, run kara I running from 1 to m and j running from 2 to m. We get finite number of lambdas. Okay, finite number of forms. Thus, there are only a finite number of elements, finite number of forms of elements, lambda of capital E, such that ai plus lambda bj is equal to a plus lambda b, where I running from 1 to up to so on m and j running from 2, 3 up to so on n. Okay, but we know that f has an infinite number of elements. F हा तुमचा कसा आहे कॅरेक्टरिस्टिक 0 आहे. कॅरेक्टरिस्टिक 0 म्हणजेच काय इन्फायनाइट फील्ड आहे. ओके सो F has an infinite number of elements. Okay, why? As the characteristic of F is 0. Okay, now also each element of F is what? In E. Okay, but F is contained in E. That is, each element of F is contained in E. Therefore, we must have an element. We must have an element E. Okay, we must have an element. Suppose that element is gamma. Okay, suppose that element is gamma belongs to E such that AI plus gamma Vj is equal to is not equal to sorry is not equal to A plus gamma B. Okay, look at here. This one is the field E. Sorry, F. This one is the field E. Okay. We get the finite number of values of what? Lambdas. There are only finite number of elements lambda of E. Okay, काहीतरी finite किती येतील काहीतरी finite lambdas येतील असे element ते कुठेतरी असतील. But F is what? Infinite. That means E also is infinite. So there exists an element gamma belongs to E. असा एक element येईल या E मधून AI plus gamma which is not equal to A plus gamma B for all I running from 1, 2 up to so on n and j running from 2, 3 up to so on n. Is it correct?
Yes, sir.
Okay, now let that element C is equal to A plus gamma B. The element ला नाव काय दिलं A plus gamma B. Okay, that implies what? C is not equal to AI plus gamma G. Okay, so that implies C minus gamma Vg is not equal to हे पुढे लागणार आहे म्हणून घेतलं बरं का. Not equal to I. Write down. Give it as an equation number star. For I running from 1, 2 up to so on n and j running from 2, 3 up to so on. Yeah. Okay. So here what we get? AI is not equal to C minus gamma Bg. Now since A, B and gamma, okay, A, B and gamma are the elements of what? F of AB. Okay, A, B and gamma are what? Elements of F of AB. A तर हा F of AB मध्ये आहेच. B तर हा F of AB मध्ये हा पण आहे. ओके F of AB म्हणजे काय तुमचा E ना is equal to E na extension of that field. So this implies C is equal to A plus B gamma. The product of these two ह्याचा दोघांचा प्रोडक्ट कशात जाईल F of AB मध्ये. ओके A plus B gamma कशात जाईल F of
F of
AB.
AB.
That is equal to C na. So C is belongs to F of AB. Okay, so this implies adjoint this C to F is contained in F of A. Okay, give it in equation number 2. Okay, if we prove that this AB belongs to f of c, then hmm, it remains to show that what we have to show now. If we prove that f of AB is contained in f of c, then these two are must be parallel. F of c is equal to
Equal.
f of AB. Okay, so there exists and C belongs to f of AB such that f of AB is equal to f of C. Okay, and that part we will see in the next lecture. Okay, tomorrow. Okay, up to here any doubt?
No, sir.
ओके हा पार्ट जो आहे ना हा पुन्हा व्यवस्थित वाचा नीट समजून घ्या ओके त्याचं एक्सप्लेनेशन हे लिहायची गरज नाही ओके याचा अर्थ एकच आहे whenever we put I is equal to 1 J is equal to 1 this solution this equation has infinite solution whenever we put I is equal to 1 to n J is equal to 2 to n we get particular lambda okay. So this is f of c is equal to f of c is contained in f of a. Any doubt up to here?
No, sir.
एखाद्या स्टेटमेंट केल्यानंतर खूप बघताना आपल्याला हार्ड वाटायचं आणि जेव्हा एक्झाम्पल घेतो तेव्हा एकदम इझी वाटतं हा आहे तुमचा क्यू ओके दिस इज द एक्सटेन्शन ऑफ क्यू क्यू रूट टू रूट थ्री okay so root 2 and root 3 belongs to what root 2 root 3. This implies but q is this is field. This is field means हा the group असायला हवा. So root 2 plus root 3 also belongs to काय root 2. Okay, so this implies हे prove केलं आपण आधी एक्झाम्पल q of root 2 plus root 3 काय असतं इक्वल कोणाला इक्वल दाखवलं आपण हा कंटेंड येईल कोणात कंटेंड येईल ओके हेच ह्याचं जनरलायझेशन आहे okay if we prove this field is contained in this field so we get what we get q of root 2 plus root 3 is equal to q of root 2 root 3. Okay, so this is the element. This is what our c. This is a. This is b. Okay. Any doubt? The remaining part we will see in the next lecture. For today, it is sufficient. Any doubt up to here?
No, sir.
No, sir.
Okay. Better not. Okay. So thank you for the attending the lecture. You can leave now.